Hey there, ladies and gentlemen. Here we go. We're starting the last unit of the year, salt and freshwater systems. And we already started this off with the lab that hopefully you guys have already started and worked on it. It's not a hard lab. Don't overthink it. Possible easy marks, but there is a little bit of critical thinking for your conclusion. Okay, so we're going to start with topic 1.1, distribution of water on Earth. I know not everybody's been watching these videos. It's kind of like PowerPointed to death here, but let's give it a go. And this one is very short. So we're going to start by talking about water on Earth. We know Earth is the blue planet. Okay, it's called the blue planet because out of all the planets in our solar system, 74% of the surface is covered with water. Okay, global warming, maybe it's a little higher now than 74%, but approximately 74% of the planet is covered with water. So we got plenty of water, right? Nothing to worry about. Okay, does that mean we don't never have to worry? 74% of the planet is water. More of it is now becoming water. Should we have to worry? Okay, is there enough water for everybody? Okay, of that 74%, most of it is salt water. Okay, which we cannot drink. So, despite the Earth having so much water in many parts of the planet, okay, the majority of the planet is water. Most of that is salt water, and in some of the areas where there is no salt water, okay, so it's landlocked, they are deserts. So there's not that much water readily available to people because there's no freestanding water, no lakes, anything along those lines. Okay, so there's no surface water. So does that now mean there's plenty of water for us? Okay. In the areas like us, we are very, very lucky because we have lots of surface water. We have a lot of lakes, okay, but some of that may not be drinkable. Okay, think of some of the lakes that you've been to, some of the nice green lakes. If you want to drink those, the water from there, okay, you drink it, then you might be having a little visit with the toilet a little bit later. If your puppy dog goes and starts drinking some of that really dirty water, maybe you have to go searching for your puppy dog. The water is not clean. Okay, think about water in the side of the road, in the ditch. Nice and fresh water, no salt and whatnot in it. Would you go and take a straw and suck some of that water? Of course not. There's bugs, there's pollutants, all those types of things. Okay. So water, that is a very important term. First only definition for the section. Water that is safe for humans to drink is called potable water. Some of you may have heard this term before, some of you may not have. It's actually everywhere. Now when you're going to be driving around when this uh, quarantine is lifted, you're going to see trucks on the side of the road or driving ahead of you and it'll have potable water written on the side of it. Okay, and it just means the water is safe to drink. So now here's the big question. This is the last question in the lab. Do you think there's enough potable water on the planet for us to survive in the future? Very important question, something we definitely have to think about. I'm not going to tell you the answer, or at least what I think. You guys are going to have to come to that conclusion. But this next slide is a summary of the lab. So those of you that have watched this video, you're going to be able to have an advantage for the lab. So of all the water on Earth, like I said, 97% of it is salt water, which we cannot drink. Okay, we cannot go into the ocean with a straw and start drinking that water. We need to have fresh water. Of the remaining 3%, so out of all the water on the planet, 3% of it is fresh. The majority of it, 77%, is locked up in the form of ice. Again, global warming might be down now, might not be as much as it was when the textbook and whatnot was published, but 77, 75, 77% of the planet, it's in ice, okay? So it's not like we can go to the ocean with a nice chipper, chop off some ice into a cup and go and drink it, or go up into a glacier up in the mountains and drink that, okay? So it's not available to us. 22% of it is groundwater. Now, groundwater is very, very clean water. There's no impurities getting down there. So if you can access the groundwater, super clean water. But there's a problem. The ground is over it. Okay. So of the 22% that's locked up in groundwater, well, that's not really accessible to us either. And then finally, we get 1% that's locked up in lakes, rivers, and wetlands. But we're not going to go and drink out of some of these lakes, some of the rivers. You know what's flowing down the river. You're not going to just go drink straight out of that. It has to be cleaned and purified. Okay. So this next number is a very important number. Okay, that's going to be coming up. So most of the fresh water in these forms is not accessible to humans. In fact, only 0.003% of all the fresh water on Earth is available for us to drink. So that's a very magic number, 0.003. Sorry, my alarm's going off. 0.003 of all the water on Earth is available to drink. So that's like the 1% here that we get our fresh water from lakes and rivers, and the 3% there. Okay, so that's the magic number. Hopefully that's the number you put on your conclusion of your lab. If it is, great, you get that one easy mark. If not, should watch this video, right? All right, have a good day, guys. That was the first video for the topic.